let me give you a moment to copy this down. Copy this example down. Okay, so let's take a look at this problem. So in this problem, can you believe it? There's a typo here. This should be if f of xy equals xy. So please make that correction, everybody. I'm going to do it right now in my notes too. Hold on, I got too much open here. I got to close a few things. Okay, so wait, hold on. Okay, good. All right, so we have this function f of xy equals xy. We want to find the gradient vector of the function at the point 3, 2, and use it to find the tangent line to the level curve, f of xy equals 6 at the point 3, 2. Sketch the level curve, the tangent line, and the gradient vector. Okay, so how do we find the gradient vector of the function? How do we find the gradient vector? What are the components of the gradient vector? Do you remember? That's right, Ryan. Partial of f with respect to x and partial of f with respect to y. Okay, that's good. That's good. So, all right, let's proceed to the solution. All right, so, well, remember, f of x, y equals x times y. Okay, f of x, y equals x times y. So the gradient vector would have components y and x. And so the gradient of at 3, 2 of the function would be equal to 2, 3. Okay, so what I've done in the picture on the right here is I've drawn, I don't really have like, notches or anything, but I just kind of estimated 3, 2. The point 3, 2 is right here. And the function f of xy equals x times y, well, we're going to draw a level curve of that when f of xy equals 6. So if f of xy equals 6, that means x times y equals 6. So that means y equals 6 over x. That's a rational function. And I know you've graphed rational functions before like that. It kind of looks like this. If you graph it on your calculator, it's going to look like that. Now the gradient function is equal to 3, 2, or 2, the gradient at 3, 2 is equal to the vector with components 2 and 3. So the vector is going to be a little taller than it is, the rise is going to be a little longer than the run is. So I, tried to just draw that there for the gradient. And also what I did on the picture was I drew a point xy. Well, I drew a tangent line to 3, 2. I drew a tangent line to 3. No, I want to be careful. I drew a tangent line to the level curve of the function. The level curve when the function's equal to 6. I drew a tangent line, and the tangent line here is tangent to the level curve at the point 3, 2. 3, 2 is on the surface, right? Because it's on the level curve, because 3 times 2 equals 6. So this vector v, okay, that we're looking for, well, no, I want to be careful. I make up a vector v here. I make up a vector v right here. There it is in blue, vector v. And it connects the point 3, 2 to the point, the coordinate xy. Okay, and I'm going to show you why we're going to use that. So the gradient of the function at 3, 2 is, what's this symbol mean? What's that symbol stand for here that I'm circling? Good, Ryan, perpendicular. That means perpendicular. Okay, so the gradient is perpendicular to the tangent line of the contour at 3, 2. And that is an observation that we have made. Okay, it's an observation that we have made based on other pictures we saw in the last class. We had a graph where we had level curves of a function and the gradient vector was perpendicular to the level curves. We drew a gradient vector and it was perpendicular to the level curves, and that is a property of the gradient function. And so, of course, if the gradient vector is perpendicular to the level curve at the point 3, 2, it's going to be perpendicular to the tangent line at 3, 2. So, well, what do we know about and so, okay, how am I getting this equation here? How am I getting this? Well, the vector v is right here in blue. This is the vector v right here. So the vector v is the difference between the point 3, 2 and the point, just the general point xy. So the vector, to get that vector, we subtract the components. But because that vector lies on the tangent line, the vector v lies on the tangent line, passing through the point 3, 2, the gradient vector, I'm going to say this right, the vector v lies on the tangent line to point 3, 2 on the level curve. Well, that means that vector v is perpendicular to the gradient vector, and so the dot product equals 0. And based off of that, you can come up with the equation of that line. Okay, so you're going to have a problem like this on your section 11.6 homework, and I wanted to just do one with you. But it's a very nice problem because, you know, it allows you to well, it just reinforces the idea that a gradient vector is perpendicular to the level curve at a point. The gradient vector at a point is perpendicular to the level curve at that point. It reinforces that idea. And actually, we're going to be making use of that actually when we talk about section 11.8, which deals with Lagrange multipliers. We're going to actually be making use of that. Okay, so are there any questions at all? Okay. Okay, one moment. All right, so we can move on, but I want to make sure that does everybody have the example copied okay, the picture and all that? Who might need a little more time? Maybe give me a thumbs up if you're ready to move forward here. All right, Deodath is good, and Robin. Okay, great. A lot of people, and Brian and Eric and Naima. Okay, then let's move forward here. So let me bring up the ebook. We're going to look at section 11.8. Lagrange multipliers. So hold on here. Let me stop the recording on this then.